everyone, welcome to the final year project presentation for group I-Lifine. First of all, I'd like to give an appreciation to my team members and to my supervisors especially, which is Sir Muhammad Rajaei bin Dzulkifli. Okay, we would like to tell you guys about the participations of our projects. First, we have participates in the 10th International Innovation, Invention and Design Competition, which is Index 2021 that was organized by UiTM Terengganu. And the second one is the final year project 5M FYP Competition 2021 that was organized by IEEE Young Professional Malaysia. Okay, what is I-Lifine? So I-Lifine, our project is an IoT-based gas leakage detector system. And we give our project name as I-Lifine because I indicates to ourselves, Li indicates life, and Fine indicates that this system is safe for everyone. Okay, so this is the problem statement that makes us want to invent this system. Gas leakage occurs every country, every day, anytime, anywhere unexpected in our daily life. As we can see, for example here, the Beirut explosions in 2020 that was caused by gas ammonia leakage. There are no early warning for them to escape their industry when there is a gas leakage. Okay, what are the objectives of this project is to invent the existing device into the device that have a lot more function for the consumers. Next one is to develop a prototype device that can be functioned as a gas leakage detector system that can overcome the problem statement before. Okay, the last one is to troubleshoot any problems that occurs after merging the software and hardware and how to overcome it. Okay, next is the project overview. This system is a device that can detect a gas leakage and give an early warning to the consumers or to the users. And then when the gas concentration that was detected by a gas detector is higher than the normal situation, it will trigger the whole system, such as the LED will turn to grey and the exhaust fan will turn on and then the buzzer will turn on also. Okay, next is, this is the system diagram of the project. Okay, for the system diagram we have user interface processing. Next one is maintenance and self-test. We have input process and output process and also the central processing unit. Okay, by referring to the system diagram, we have list out the project block diagram, which is we have 2 input and 4 outputs for this device. Okay, next one is the system flowchart. Okay, by referring to the input block diagram, output block diagram, also we have invent the rough idea. We have do the rough idea for the system how to flow. Okay, next one is by using the input output block diagram, and then by using all the components that was list out, we have do the circuit design in the Proteus design suite. For the hardware development, next I will pass to my mates Fakhrur Hafizi to present it.
Alright, thank you Aster for the explanation to our panel. And now let's continue our presentation here. Alright, let's go further without wasting time. And now I will present to our panel on our hardware prototype. This is our latest prototype that have we considered many times, and this is what I will get. And next is our code is on the first and the second image. It's about how the works of the inputs we setting and the output we want to produce. And for the next slide, and this is the further of our coding is that explain on how the output control the input and how the data is sent to the Wi-Fi module. In the apps interface, we use MIT Investor to collect our data from the Wi-Fi module that got recorded from the input. We gather all the information and make a graph to make the real time of checking the concentration of gas to make sure that it's not reached in critical level. And without further more, we go to our result. If we apply the gas, which is the LPG gas, to the MQ135, and the concentration of gas will rise up. And After a certain times, alright, the red LED will light up and the buzzer will on. Next, the reading from the MQ135 sensor will go to the Wi-Fi module, and the value given by the Wi-Fi module will be displayed in the MIT investor. First, our reading value will be recorded from the MQ135, and next will be sent to the Wi-Fi module through our home Wi-Fi to the cloud apps, and the value will be recorded itself in the clouds, and the recorded value will be collected for each time this device send the data, and it will create automatically the plotting and will make a graph for the concentration of the gas. And next, our output to turn on the DC motor is by mechanical movement, which is press the switch button, and the same goes to the result, which is both LED will light up and the DC motor will turn on. But in this case, the DC motor do not have enough voltage to produce the output.
From the video before, we got a few problems from the device itself, which is one of them is the motor doesn't rotate because it doesn't have enough power to run the DC motor with the propeller. And the solution is to put the high voltage source, which from the 5 volt to 9 volt that is recommended for the motor itself. Next, our device doesn't have enough airflow that have efficient airflow to suck out the dangerous gas out of the area. And for the solution, we create a hose pipe that can fit the diameter of the DC motor to create an efficient airflow to suck out the gas out of the house. To conclude our findings in this FYP2, we found that the function of every gas sensor was understood. Second, the coding and the library for each component for our device was determined. And the third one, we able to save life early with the warning leakage of the gas sensor itself. Last but not least, we also recommend some of future update, which is one of them is to add GPS module to our device to make the user easy to locate the device itself. And second is to add GSM module to make sure the device send the alert notification to user efficiently without the internet connection. The third one is to add a function that automatically call 999 for the emergency happen. And I guess that's all from us. Thank you.